So on today's episode, I would like to take you guys through some data analytics. So the last time we installed some packages such as xarray and then other necessary packages, how to store Python. So today we would like to do data analytics using xarray in Python. Yes. So first of all, press Ctrl+Alt+T, or you can go to the menu. You can come to this side, then search for your terminal. This is the terminal. Yes. Okay. So now we are opening the Jupyter notebook to start our data analysis. So we just type Jupyter notebook. Then you press enter. So it's loading. Okay, so it has opened. So this is the Jupyter notebook. So last time I sent you guys some files, some precipitation files. Yes. So you can get all files. You can get some of these files. That's the atmospheric variables such as precipitation, temperature, and the rest at many of the sites. We have many sites such as ECMWF and then crew and many more. Yes. So we'll be using this file. The last time I sent you guys this file, it's a precipitation file from 2011 to 2020. Okay, so first of all, you can create a folder. As I've created mine, you can create a folder such as this. So and then you name it tutorials, and then put that files inside. So first of all, this tutorial folder is on my desktop. Yes. And then the file that we need, that's the precipitation file, is also in the tutorials. So to locate this, we go to this. You go back to the Jupyter notebook. Then we go to desktop. Okay, so then we will search for tutorials. That's the folder that we created. Okay, yeah, so this is the folder that we're talking about, that's the tutorials. Okay, so now we have to create a new file, new Jupyter notebook. Then we start working on this variable or this data. So it is so today we'll be dealing with netcdf files. So we can netcdf files we use xarray. Yeah, in dealing with netcdf files. Okay, so to create a new Jupyter notebook, you just have to click on new here. Then you can see terminal, folder, and then test folder. Then you click on the Python 3 kernel to create a new one. Okay, so here is it. So you can click here, the file, then we click rename. Yes, in order to easily identify your notebook. So we can do it tutorials. Okay, yes, so here's the new name. Yes. Yeah. So first of all, we have to import some packages. That's the package that we'll be dealing with. Yes. So import xarray as xr. Then you click on shift enter, or you can come and click on run here, this one, to run this notebook. Okay, so just finish loading. So first of all, we want to see what this directory contains. So we just press on and type ls to view what this directory contains. So we can see it contains crew ts_4.2021, then 8/2011 to 2020, then tutorials, and then tutorial. So now what are we dealing with? We are dealing with the precipitation data, that's the crew. So in order to open the CDF files, as I said, we use the XR function. So we just use something like, you must assign it to a variable name. So I'm using a variable name as maybe ds_precipitation. So the ds means it's a data set. Yes, so ds underscore. So then we type xr dot open underscore data set. Yes, then you bring your open brackets, open and close brackets. So then as I type, so you can just copy this file name, that's the crew, and as you can just copy everything up to .nc, then you paste it here. So crew, yes. So first of all, we are trying to open this file. So then after everything, you just type shift enter or run the cells again. Yes. So since there's no asterisk here, and then we can see 3, it means it has loaded successfully without any error. So then to view this file, just press ds_precipitation. So yes. So what this function means is that we've now assigned the file to a variable name called ds_precipitation. Yes. So now to view the information of the file, we just press something like shift enter again. So you see there's some asterisk there, it means it's loading. Yes, so this is the file. So now we can see the time, the long and lat. So the long is the longitude, and then the lat is the latitude. So if you don't view the file, you won't know the variable name that are assigned to it, the full name. So that's the short name, the coordinates, and then we can see some data variables, some 2 data variables, that's PRE and then STN. So the PRE is precipitation, and then the STN is the stations. Where the stations where they were recorded. Yes. Okay, so you must also make sure that the range that will be taken, as in the longitude and then latitude, must be within this range. So we can see -179.75, -179.2575, meaning it's ranging in 0.75 and then 0.5. Yes. And then 179. So yeah. So if maybe your coordinate is not within this range, then you use something like method equals to nearest. Yes. So first of all, we are done. So our next step, we are done viewing all the files, coordinates, data variables, and then the other. So we have the attributes also here. You can just read everything. Attributes, you can see that this data was from climate data interface version, and then other source of information, crew. Yes. Yes, and the CD version that I'm currently using too. Yeah. Okay, so the second step is that you have to select your data variable. Your data variable, as in, we can see PRE, that's the precipitation, then that's the station. Sometimes you can see multiple here, as in maybe TMP, that will be temperature, and many more. So now you select what you want to deal with. Okay, so right now I want to deal with precipitation. So I will just use DA underscore precipitation. So the DA assigned to this means it's a data array. The first one here is a data set data array. So data arrays are under the data sets. Yes. So meaning we selected data array called precipitation and STN. So which is equal to. So we are assigning this into DS underscore precipitation. Now we are selecting the variable name precipitation. So you use something that you use dot pre, then you run shift enter again or run. Okay, so yeah, I mean there is no error, meaning right now we have only selected the variable precipitation, leaving the STN. Yes. So now we run DA underscore precipitation. Yes. Okay, so now this is the information about the precipitation. Now you see there is no STN. Yeah, and we can see X array dot data array. That is, so now our data array is precipitate. That is the P array. So the time is 120 times steps, and then the lat is 360, and then the long is 720. Yes. So for today we'll be dealing with all the time series. The next time we're going to continue with special plots. Yes. So now we've assigned the precipitation to a variable name called DA underscore precipitation as a data array. So right now what we have to do next is to select our coordinates. That is the longitude and then latitude. And if maybe you want to take some time of it, maybe you have a very huge data ranging from a wide range from maybe the past, and maybe you want to select some specific time. Yes. So we use maybe, so right now I'll use something like PRE is equal to DA underscore precipitation. Sorry, precipitation. Then you use dot cell and you use dot cell into brackets long. So that's it. Now the name here is long. So if it was in longitude, you would have typed longitude. So now it's in long, then you use long. So I want us to work for this country, Madagascar. Yes. So then you go and search for the coordinates of Madagascar. So long equals to 46.75. Then you type the lat. You can do it for every country that you want to use it for, but in this case, in this tutorial, I'm doing it for Madagascar. Negative 18.75. Okay. Okay, so now we selected the coordinates, left with the time frame. So look, I did 0.75 because I was that's not the exact coordinate. I was just making sure they are within this range. Okay, so now the time is ranging from 2011 to 2020. So maybe we want to work with maybe 2012 to 2020. We just bring a comma here. Then it's not time, it's not daytime, it's time. So we just select time equals to, then you select the range that you want to deal with. That's the range that you want to deal with. So let's say from 2012, then you bring comma here, so another comma. Yes, so 2012 to 2020, then Okay, so now what this code means is we are selecting a time frame of 2012 to 2020. Yeah, so sorry, we have to bring, we are slicing a year. So after bringing the time equals to, then we bring slice into bracket. So we are taking the year, as we said, from 2012. So we just bring quotes 2012, then to 2020. Yes. So don't forget this one. That is the slice. Meaning we are taking from 2012 to 2020. So we use the slice when you want to take some range of years. Okay, so there's some error which is saying incomplete data. So yeah, so it's supposed to be one close bracket, then you press shift enter or run again. Yes. Okay, so as you can, there's no error again. Then you type in pre again. Okay, so from here we can see that you select. It's not showing from 2011 again. It's now showing the time frame that you selected. That's from 2012 to 2020, and then the long and then latitude that we took. That's what it's showing. And then as it gives info that the long name for the precipitation, and each unit is in millimeters per month. So now if you check the unit and then you're not okay with the unit, you can also use some computational skills to also convert the unit. Yes, maybe to meters or whatever it wants to do. But precipitation is measured in millimeters, so it's okay for us. Yes. Okay, so now we are done with everything. So what we have to do is, maybe you want to group, you are dealing with months, you want to group your data according to months, days, or years. Okay, so if you want to do that, now we want to assign this to month underscore precipitation or month underscore precipitation. Okay, so as for the variable name, you can give it any variable name. Yes, but just follow the steps. Yeah, so that you won't repeat anything. Yeah. Okay, so so month underscore precipitation, which is equal to, now from the previous variable that we assigned it was pre. So now we are currently on the variable name pre, the PRE. So the PRE, that's where we selected our coordinates and everything. Yeah, and the time frame. So we are using the PRE. So PRE. So now what we want to do is that we want to see the monthly variation in the precipitation. Yeah, so meaning we are going to deal with months. So month underscore precipitation is equal to PRE dot group by. So we are using the group by function to group them all according to months. Yes. So group by, then okay, so since we are selecting it over time, then you bring time, this time, so time dot, so mean we are grouping the time into months. So time dot months. Sorry, you must make sure they are all in quotes. So time product group by time dot months, then dot sum into bracket time. So when it's done grouping them into months, it will just sum up everything. So sum time. Yes. So then you run it again. Okay, so there is some error which is saying daytime object has no attribute months. Yes, so it's actually months, not months. So just come and clean the S. Yeah. So month underscore precipitation is equal to PRE.by. So what this code means is that we are grouping all the months. We are grouping all the time into months. Yes, and it will sum over everything and then assign it to a variable name called month underscore precipitation. Okay. So since there is no error that we can see line 24, it means that's run successfully. Then we type in month underscore precipitation, then shift enter again. Yes. So as you can see now, the unit is in millimeter per month. As you can see, X array of data array, P array, month, so 12 time steps. So it means that group all this data according to 12 time steps. That's 12 months. Yes. So now we are done grouping it to months, so we can make a time series plot. So sorry. Yes. So now we assign to a variable name called month underscore precipitation. So now we can do a time series plot by typing month underscore precipitation. Then you bring something like dot plot. Then open and close bracket. Then you type you run this line with shift enter. Okay, so this is the plot, the month. This is the plot of the precipitation of Madagascar from 2012 to 2020. So now what we can say about this plot is, so Madagascar experienced high precipitation. That's one. We can see one here. So the one is from here. So one, that's January. So here is the months, as you all can see, months, and then here's precipitation. So the precipitation was very, very high in January, February, then March. Then it decided to drop from April, May, June, July, August. Then it decided to run in September, October, November, then December. Yes. Okay, so now we can also design this plot to make it look somehow nice here. So we must first go top there and import another library. So that's import Matplotlib dot pyplot. Import Matplotlib dot pyplot as plt. Yeah. Yes. So now let's go back there again. Okay, so this all, and I want to design this lithograph. So you just use, you can also rename your access if you want. So maybe plt dot y label. That means we want to rename the y axis, or we want to name the y axis. So the y label, we're going to bring into bracket the codes. So y label maybe precipitation. Then we run the code. Okay, now yes, so we can see the precipitation here. So you can also color it. You can also give it a color. So color equals to, then you bring your codes out. So that means I want those areas to be red. The precipitation name to be red. Yes. So we all can see it as change to red. So maybe you want to also rename the x-axis. Then also type plt dot x label. That's months, right? So then you put into bracket months. Then maybe a color for it. Color equals to maybe so blue or green. Yeah, let's use green. Okay, yeah. So so we are done with the renaming of the plot. So you can also so you can also give it a title too. So maybe plt title. Then you bring it. So what I want to do is maybe you give it a title. That's the name. So maybe I'll name it as monthly precipitation variation across Madagascar. Yes, then run it. Yes. So you can also change the color of it, maybe color go to maybe yellow. Oh, so faint. So maybe color equals to violet. Yeah, so you can change the color according to maybe what you want. Yes. Yeah. Okay, so now from here we can insert some designs such as marker. Maybe marker equals to small o. Yeah, so these are the markers. Or you can also do it as asterisk. Yes, so asterisk. So you can also use the exponential sign for triangles. Or yes, so the exponential sign is for triangles. Okay. Then you bring a comma. Maybe you want to change the color, so color, that means you are changing the color of this the plot. So color equals to black or red. Color equals to red. Okay, so we are done with some parts. So you have to label it so that when someone looks at it, he can know the type of variable that we are dealing with. So maybe label equals to bracket quotes precipitation precipitation. Yeah, so then you run it. Okay, so from the down there, you just have to press enter. Type plt dot legend. Then you bring it. Yes. So in this case, that function will let the precipitation to come here. That's it. So maybe we had multiple data, maybe precipitation against temperature. Yes, in this case we use this legend and this label to distinguish them from messing up. Okay. So legend. So you can also describe the location that you want this legend, the precipitation to be, this label precipitation to be. So you can also do that something like log equals to quotes upper left. Yes. Upper left. So we can all see it here, or bottom left. Sorry, it's not bottom left. I've forgotten that one. Either down left or I've forgotten that. So it's like so let's use the upper right. Then you run. Yes. So we are done. We can also decide to increase the font size of the precipitation, the naming of the x-axis and the y-axis by using font size, and even the title too, by using font size. So from here, and we bring comma, font size equals to 20. So meaning the font size of precipitation, the y label is supposed to increase. Okay, so there is an error. Okay, so it seems here, sorry, I was increasing the size of the y label, not the marker. So Control X. So this is the y label, plt.label. Yeah. So we just bring comma, then font size 20. Yeah. Okay, yes. So we all can see that the size of the precipitation has increased. So we can adjust it to whatever you are comfortable with. Yes. Okay, now let's try and group them into years, and let's see. The first one, the first one already, we group them according to month. You group the time over month. So now let's group it into But first of all, you can also change the naming. Maybe you want to change it from, since we are doing it month, you want to change it from January, February, March to December. Yes. You can also do that. So maybe I'll come to the top here. Yes, and then maybe on this side. Sorry, let's go to the down there. Okay, so maybe you want to rename the x-axis maybe into January, February, very much, maybe you don't want the numbering, you can just come to this side, then press A so to create a space above. Yes, or you can come to this side. You just click on the left side and then you come to this side. So then we come to here, insect. So it's above or below. Yes. Okay. So now what you want to do is you want to type month equals to, then bring your square brackets, Jane. You must make sure they are all in quotes, so Jane, comma, Feb, Feb, comma, April. Yes, so I've typed all the months. Then you come and you run that code again. Yes. So after typing all the months, okay, let's come down. So you run a cell below. Yes. So in this case, you'll be using the function plt dot plot. So we are plotting y against x. So the y is month. So we are plotting y against x. So month underscore precipitation. So we'll be plotting month against precipitation. So we're plotting month against month underscore precipitation. And then run it. So you can see that there has been changes. So now here is the month. Okay, so we can also edit this code to pick that one up by you bring it, you type enter, then you go and copy that code, or you just type plt dot plot into brackets month, comma, then month underscore precipitation. Then you block this one by using shift hash. So you can come and also copy what's inside. You can type everything, marker, color, then label, everything. So Ctrl C, then come and place it here. So I'm done. You can just run them like shift enter. Able to pick it up. So this is the month as in June, February, March, April, May, June, July, August, September, October, then precipitation, everything is intact now. I wanted this to do for the years, but there's an atmospheric interaction, so we will continue next time. Thanks for listening. Bye.